Hi, I'm Adolph Oliver, and today we're going to take a look at translating inequality expressions. This is a step toward being able to solve inequalities that are like equations, but instead of course having an equal sign, they have one of the inequality signs. Let's remind you what all of those are. There, of course, is the less than sign, the less than equals sign, the greater than sign, and the greater than an equal sign. Now, one of the things that's nice to remember about how these inequalities work, they're basically a sideways V, and there's always a small side and a large side. And it works out very nice because the small number goes on the small side and the large number goes on the large side. So you always understand how things like this work. Now, of course, the real use of inequalities is not telling you that 2 is less than 3. I mean, we know that. But if we want to indicate a range of answers, x is greater than 5. This means all the x values have to be larger than 5. See, the large side is toward the x here. And since we don't have the equal bar like these other guys here, x would have to be strictly greater than 5. Okay, well now, what we want to be able to do is work with these expressions and translate them, and that will give us the beginning steps toward being able to translate a full inequality and solve it. So here's the key in how to work with these. The key to translating any inequality expression is to ask these three questions. Can the value be more? Can it be equal? Or can it be less? Can it be more, equal, or less? The answers you give to that will tell you exactly which inequality symbol to use. Let's give you some examples of these here. For instance, as I said here, there are many different phrases that can be used to indicate an inequality, and there's no way in the world that the examples I'm showing you here exhaust all of them. But there's some examples. Okay, for instance, this first one, less than 3. Well, we're referring to 3, but now here's the question. Can it be greater than 3? No, we got to be less. Can it be equal to 3? No, we got to be less. Can it be less than 3? Yes. Okay, so if we were using, for instance, the variable x here, we'd say, okay, our values have to be less than 3. So let's go on and look at the next example. More than 7. Okay, well, we're referring to 7. And can our value be more than 7? Yes. Can it equal? Well, if you've got to be more than 7, it can't equal 7. And, of course, it can't be less. So, in this case, the x would have to be greater than 7, meaning the x is larger. It's more than 7. Now, the next one up, at least 5. Well, okay, we're referring to 5, and we have to be at least 5. That means, of course, that's the lowest our value can be. So, can it be more than 5? Yes. Okay. Can it equal 5? Well, it has to at least be 5, so 5 would work. Can it be less than 5? No. So, the ones we said yes to were can be greater and it can be equal. So, here we are. The greater than, indicating the x is larger, and also equal. Okay, well, you get the hang of how this goes. Let's continue on with some more examples here. The next one up, no more than 9. Okay, well, I'm referring to 9. We cannot be more than 9. Okay, so we ask the three questions. Can you be more than 9? No. Can you equal 9? Well, if 9 equals 9, that's not more than 9, and our requirement is we cannot be more, so 9 would work. It can be equal. Can it be less? Well, if we're no more than 9, being less is okay, so we can be equal to 9 and we can be smaller, so here we go. Our x is going to be less than or equal to 9. Okay, next example to take a look at here. At most 2. Okay, well, we're referring to 2. 2 is the most we can be, meaning we can't be larger than that. Okay, well, ask the three questions. Can we be more than 2? No. Can we equal 2? Well, at most we are 2, so we could equal 2. Can we be less than 2? Yes. So our x here, we can be less than or equal to 2. At most 2 means we have to be 2 or smaller. Okay, here's another phrase that you could bump into. Must exceed 4. Okay, we're referring to 4. We must exceed it, meaning we must be larger than 4. Ask the 3 questions again. Can we be more? Yes. Can we be equal? Well, we must exceed 4, which means we can't be 4. We got to be something larger. And can be less? No. So the only thing that can happen here is the x has to be larger than 4. It must exceed 4. Now, of course, if you get someone phrased just like one of the inequalities here, that's great. Right here we see we've got less than or equal to 6. Well, here we go. We're referring to 6. Can we be more? No, we can only be less than or equal. Can we be equal? Yes. Can we be smaller? Yes. So x less than or equal to 6. Very seldom you're going to get the phrase coming out exactly in the name of what the inequality is, but hey, when you get lucky, that's great. Okay, let's look at one more example, then we'll look at some of the actual problems. Cannot exceed 8. Okay, here we've got 8. Now, can we be larger? Well, we can't exceed it, so no. Can we be equal? Well, if 8 is 8, then we're not exceeding 8. We just can't be anything larger than 8, so equal is okay. And can it be smaller? Well, yeah, smaller as long as it doesn't exceed. So we can have a value which is smaller than 8 and also equal to 8, so less than or equal. So as you've seen in working through just some of these example phrases, what it boils down again to is asking these 3 questions. Do the wording that I have here, does it indicate that we can be more than the value given? Can we be equal to the value given? Or can we be less than the value given? And your answer to these questions will tell you exactly what inequality to use. Well, now let's start looking at some examples of these. Here we go. The first one coming up says the sum of a number and 8 must exceed 48. Now, they didn't say must equal 48. Must exceed is a phrase which indicates you've got an inequality. Well, let's make up what we've got here. The sum of a number, and we can use any variable we want. Let's say we use n. The sum of a number and 8, so this is going to be n plus 8, must exceed 48. Okay. Now, this guy right here, can he be more than 48? Well, he must exceed, so yes. Can he equal 48? No, you've got to exceed it. Can it be less? No, because you must exceed, so n plus 8 must be greater than 48. Okay, there's the inequality translated for us. Now, let's go ahead and actually solve these guys up since we have them here. And remember, we talked about solving inequalities before. You, of course, want to have just a variable on the left and a plain number on the right, just like you do with equations. So the guy that's on the wrong side is the plus 8. He's got to jump over the other side where his sign changes and he becomes negative 8. Okay, well, I've moved the plus 8. So now I have n on the left and 40 on the right. Now, the only time you flip the inequality sign is if you completely interchange the sides. We didn't do that. We just moved this one guy. Or if you multiply or divide by something that is negative. And we didn't multiply or divide at all. All we did was move this guy, which is basically doing the add and subtract principles. So, no reason to flip the inequality. Here it is. N greater than 40 is our answer. Now, let's remind you of a few things. How could you make this into set builder notation? It's very simple. Put the vertical line in front of the n. That's the such that line. Whatever variable you have, and that's our n. Okay, put that in front of the line, and then put the curly brackets around it. Remember what this means is all values of n such that n is greater than 40. Okay, and what that allows anyone to do seeing this is build up as many values of this n as they care. That's why they call it set builder notation. Now, one last thing on here, of course, let's take a look at grafting something like this. And here's a number line. If this is 0 here, somewhere way over here would be 40. I'll just mark this spot and say that that's 40 right there. And now we want our n's greater than 40. Well, remember, there's no equal bar here, so n has to be strictly greater than 40. That means that we make the open circle around 40, and of course if n is greater, then we indicate with the arrow n getting larger to the right. So there are always different ways of giving the answer. The basic is just n greater than 40. You can make set builder notation out of it like this, and you can turn around and graft it. But of course, to be able to graft it, you've got to simplify it down to what we have right here, n greater than 40. Okay, let's look at another example here. Here's the next one we're going to take a look at. 12 more than a is greater than 24. Okay, 12 more. Now, first off, greater than, that indicates we've got an inequality. They didn't say 12 more than a equals 24 or is 24. It says is greater than, so that's how you know you've got an inequality. Now, 12 more than a. Well, 12 more means we're going to be adding 12. We're going to add it to the variable a. So I could write it like this. Here's the a plus the 12 more. Now, that has to be greater than 24. Okay, so we're going to have, of course, the 24 we're comparing it to. What I just wrote here has to be greater than that. So, we asked the three questions. Can it be more? Yes. Can it equal? Well, no, it's got to be greater. Can it be less? No, it's got to be greater. So, the only one we said yes to was greater. Therefore, this whole expression right here has to be greater than the 24. Here it is. Okay, let's go ahead and solve it once again. And we've got to move the plus 12. It comes over as negative 12. So I end up with a greater than, well, positive 24 minus 12 gives me 12. Okay, so there would be our answer if we just wanted it as an inequality. Making set builder is easy. Put the such that line. The variable is a. Put that in front. Put the curly brackets around it. There's set builder notation. Now, if we wanted to graph this, no difficulty. Of course, we have to have it simplified like right here. So if this was 0, let's say, and this was 12 on my number line, once again here, we look at the inequality to see what kind of circle we're going to make. There's no equal bar, so that means we make the open circle, and the a's have to be getting larger than 12. Well, which way do numbers get larger than 12? Going over here to the right. So there's the whole thing for us. Okay, these are not difficult to work with. Let's go on to the next one here. 9 less than d is less than or equal to 23. Okay, less than or equal to, that indicates we've got an inequality. Now, first we set up our expression here, 9 less than d. Remember, 9 less means you're subtracting, and whatever you're subtracting has to follow the minus sign. So 9 less means we're subtracting the 9, it has to follow the minus sign. The d is what we're subtracting it for, it goes in front. So remember, when something is being subtracted, it has to follow the minus sign. Okay, well, that's our expression. We're going to be comparing it to the 23 over here. Now, what can this guy be? Well, he's got to be less than or equal to 23. Can he be larger? No. Can he be equal? Yes. Can he be less? Yes. So less than or equal to 23. Okay, well, there's our translation here. Now, let's go ahead and move this one guy that's on the wrong side. The minus 9 has to come over as plus 9. So I end up with d, and remember, when you move things, you never have to flip the inequality. So there it is. We're leaving it exactly the same. 23 plus 9, 32. Okay, so any value of d less than or equal to 32 will satisfy our requirements. Again, to make set builder, put the vertical line in front, the set that line, our variable's d, so we put that in front of the line, put the curly brackets around it, and there is set builder notation. Now, to turn around and graph this guy is not difficult. Let's say this is 0 here and say 32 over here. Now notice the circle that's going to go on our boundary now, since there's an equal bar here, is going to be solid because 32 is a possible answer because of the equal bar. So we make a solid circle. Now, which way did the d values go? Well, they've got to be smaller than 32. Remember, the point here, the smaller side, is pointing toward the d, so that means they're smaller. So everybody to the left here, there's my arrow indicating that it can be any of the values 32 because of the solid circle or lower. Okay, here's another one. A number times 12 is no less than 8. Okay, no less than. Again, we're not saying a number times 12 is 8. Is no less than 8. So that again indicates to you that it's one of these inequalities. Okay, a number times 12. So we've got some number. Let's say it's n. And we're going to be multiplying 12. So I could do it like this, n times 12, or I could have written the 12 in front of the n. But anyway, here we go, and we're comparing that to 8. So a number times 12, here's a number times 12. Parens indicate we're multiplying it. Now, is no less than 8, meaning it cannot be smaller than 8. Okay, well, can it be larger than 8? Yes, it just cannot be less. Can it equal 8? Yes, it just cannot be less. Can it be less than 8? No. So it can be larger than 8 and equal to 8. So there's our inequality. Okay, well, here's what we have to do to solve this. I've got to divide both sides by 12. Now notice, we are dividing by a positive value, so that means we do not have to flip the inequality. If we had divided by something negative, we would have had to flip this. But since it's positive, that's not the case. The 12s reduce. I get n greater than and equal. The inequality stays the same way. Now, don't forget to reduce this. Fractions must always be reduced in final answers. 4 goes into 8 twice. 4 goes into 12 3 times. So we have n greater than equal to 2/3. Okay, well, there's my answer written just as an inequality. Any value of n greater than or equal to 2/3 will satisfy our requirements. To make set builder again, put the set line, the variables in, put that in front, put the curly brackets around to indicate that's the set of the answers. Now, how to graph something like this? Well, the number line works perfectly fine, whether you have integers, decimals, or fractions. So, for instance, if this was 0, and let's say that this was 1 here, then 2/3 would be 2/3 of the way between, let's say right about here, would be where 2/3 would be. Okay, well, that's our boundary. Notice we have the equal bar, so that means that what we're going to do here is we're going to be making the solid circle. So here it comes. There's our solid circle. And now the value of n has to be getting larger. Remember, the large part of the v is pointing toward the end. Which way do values get larger? Over here to the right. So there would be what it would look like if we were to make a graph of the answer. Okay, here we go. Next up, a number cubed is greater than 14. Okay. Well, let's say that our number is x, and cube means we're raising it to the 3rd power. Squared would be that we're only raising it to the 2nd power. So, for instance, here would be x cubed. Now, is greater than, okay, well, notice that it's not saying that a number cubed is 14. It's just greater than 14. So, we're comparing it to the 14, but this is the guy we're talking about, our x cubed. And it has to be greater than the 14. Okay, well, asking the three questions again. Can it be larger? Yes. It can be greater. Can it equal? Well, no, it's got to be greater. Can it be less? No. So we simply have x cubed greater than 14. Now, we haven't studied yet how to take cube roots and do things like that. That's in your algebra future. So we'll just leave this one translated right like this and won't solve it any further. You have to know more things to be able to solve this guy. Now, coming up next here, another one that we can identify again as an inequality. The difference of x and 14 is less than. Okay, we didn't say the difference of x and 14 is 48. That would be an equation with an equal sign. But is less than, that means we've got an inequality. Now, remember, here's this word difference. Difference, of course, means we're subtracting, but difference is the only word you can use for subtraction where you assume that the numbers are given in correct left to right order for the subtraction. Okay, in all other cases in subtraction, you have to figure out what's being subtracted, and it has to go behind the minus sign. Well, difference is the only one that has this special rule, and remember, it just come down through the history of mathematics. That's why we have it. Okay, well, then my guy on the left is x, the guy on the right is 14. So I have x and 14. The difference means we're subtracting them. So because they use word difference, I just took these in left to right order. Okay, well, now we're comparing this in the inequality to 48. And this guy right here, our difference, is less than 48. Okay, ask the three questions again. Can it be greater? No. Can it equal? No. It's got to be strictly less than. So there it is, the smaller side pointing toward our expression over here. Now, this is one we can solve. Let's do it. The minus 14 can come over as positive 14. We've moved the 14. Now I have x. And remember, when you move things like this, you don't flip the inequality. It's only if you multiply or divide by something that is negative. Well, let's see. 48 and 14, that's going to be what? 50, 62, I think, both positive. Okay, now, once again, easy to make. Set builder notation. Put the such that line, put the variable in front of it, and put the curly brackets around it. Remember again what this means. All the x's such that x is less than 62. And if you follow that rule, you can write as many x's here as you want. And that allows someone to build up the set as far as they want to go. Grafting again is simple. Okay, we got x less than 62, and we always have to solve our inequalities to get them down to just the variable on the left here and the rest of it over to the right. X less than 62, well, let's say this is 0, and let's say way over here someplace is 62. Now, this is my boundary line. There's no equal bar, so I make the open circle indicating that 62 is the boundary, but my x cannot equal 62. And of course, notice the small side of the inequality is pointing toward the x. That means the x's have to be getting smaller. So which way do they get smaller in the number line? To the left. So there would be the graft of that. Okay, let's look at one last one here. We're going to bump into that special word for division as well. Remember, just a little while ago, we had the word difference, which means we assumed correct left to right order when we were doing subtraction, because difference, of course, indicates subtraction. Quotient is the word for division that means correct left to right order. So here we go. This would be the guy on the left. This would be the guy on the right. The guy on the left is a number. Let's use the letter N. The guy on the right, they give us to us as a 2. Okay, well, a quotient can be written different ways. You can turn around and write it as N divided by 2 horizontally, but what we do more in the algebra is write the division as a fraction. Here it is, N divided by 2, so we are definitely running it left to right. Let's remind you again that if you wrote it correct left to right order here, you'd have n divided by 2. All I've done is written this guy as a fraction right here. Okay, well now, we've got to compare him to 10, and is less than. Okay, that again indicates to us that we've got an inequality. So my expression over here with the variable has to be less than 10. Okay, we'll ask the 3 questions. Can it be more than 10? No. Can it equal 10? No, it's got to be less. So, of course, can it be less than 10? For sure. So here you go. N over 2 is less than 10. Well, now to solve this, I've got to get rid of n divided by 2. So let me multiply this side by 2. That means, of course, I've got to multiply the other side by 2 to maintain my balance. And I'm multiplying by something positive, so that means I don't have to flip the inequality. The 2's cross cancel here. The inequality stays the same way. And 10 times 2 is 20. Okay, well, again, very simple to make set builder notation out of this. Put the set line. The variable happens to be n in this case. Here's the curly brackets indicating the set. And, of course, if we wanted to graph this, it's simple to do. Let's say this is 0 over here, and over here someplace, like here, we have 20. Well, 20 is my boundary. There's no equal bar here, so that means I make the open circle, indicating that 20 is the boundary, but n cannot be 20. N has got to be values smaller than 20. How do I know that? Well, look at the small side of the inequality symbol is pointing toward the end. Which way do numbers get smaller from 20? Well, going to the left. So there we are. There's our graph of it. So again, when you give answers here, you can give them just as a plain inequality. But if set builder notation is required, that's easy to do. And if you need to graph it, that's also easy to do.